Y'all hear me? There's only three of y'all there so far. Can y'all hear me?
Yes, sir.
Yes.
Thank you. I won't be right back because I am back. You might. Uh-oh. Please be sure your name is in chat. Somebody doesn't have their name in chat. Me, other than me. All right, I'm not sure how far we got into this. One notation I have left to myself said we were at slide 633, and I don't know if that was for this class or for my previous class. Did we discuss determinants last time?
Yes, we did.
Please be sure your name is in chat. All right, so we talked about how to find a determinant of a 2x2 matrix. So we had the main diagonal and then the diagonal going in the opposite direction. We take the product of the main diagonal and we subtract the product of the other diagonal. The diagonal going in the opposite direction. Opposite always means. I believe I did. I'm answering somebody in chat. They sent me a direct message. Yeah. The next, I did talk about this in my 10 o'clock. I did talk to it in my 10 o'clock. The next exam, I know on the schedule it has it for next week. It won't be next week. It will be the week after Thanksgiving. So the Monday after Thanksgiving will be the review. And then Wednesday will be exam 3. So what we finish up today and Monday and possibly on Wednesday is fair game for the exam, as well as all that stuff about logarithms. With logarithms, a lot of it is going to be, you will have 6 problems about changing a logarithm to an exponential and an exponential to a logarithm. You will be solving logarithmic equations, and you'll be writing single logarithms as sum or difference of other logarithms, or you'll be rewriting an expression involving logarithms as a single logarithm. Some of these you'll writing several logarithms as a single logarithm. That will probably, you'll probably see that in solving for solving an equation. And then determinants will be on the test. And we're going to get into sequences a little bit, but I don't know if that's going to be on the test. I don't know if we have enough time for people to really get into it. So yeah, so the next exam will not be next week. It will be the weekend. Because after Thanksgiving, we have 2 full weeks before exam week. Okay. In exam week, you only show up to class on the day you're having your exam. So if the exam in here is on a Wednesday, the final exam is on a Wednesday, then I won't see you on Monday. And if the final exam in here is on Monday, then I won't see you on Wednesday because you'll be back. What else was I going to say? Oh, and that also means we'll have the first full week of December. We will have 2 days for a review for the final. The final will have around 20 questions on it, plus or minus 5. So, and you'll have 2 hours to do the final. That answered and alleviated some questions and concerns people may have had about the next 2 exams. All right. Now back to determinants. So to find this determinant, we do 2 times 4 times 2, and we're going to subtract 7 times a negative 1. So 4 times 2 is 8, and 7 times 1 is a negative. Go days without getting phone calls, and all of a sudden I'm getting a bunch of them today. And they're all spam calls. And so 7 times negative 1, then we're going to subtract this product. So we're subtracting a negative 7, so that means we're adding 7. So it's 15, 8 plus 7. That's the determinant. Now, determinant isn't an end of itself. We use determinants to find other things, which is, we'll get to that in a moment. Kramer's rule, I think we did this already, right? We talked about Kramer's rule.
Yes.
Where we have the determinant of the coefficients, which is the denominator of these 2 things. And then we have the determinant to find for where we replace the x coefficients with the constants. And then for the y determinant, we're going to replace the y coefficients with the constants. Okay. And now we can do this provided that the determinant of the coefficients is not 0, because we can't divide by 0. We won't. It does. We can't find the solutions this way. So I believe I stated if we're trying to find 2 unknowns, then we have 3 determinants to find. The determinant of the coefficients, so that's going to be the denominator of the 2 fractions. And then d sub x, which is replacing the x coefficients with the constants. And then d sub y, which is replacing the y coefficients with the constants, and then finding those 2 determinants. And so we need to find, did we work this one? Or did we stop here?
We worked this one, I believe.
Our treasury is filled with gold, and I think it could be wise.
So, someone needs to be muted. So the determinant of the coefficients, we get a -4 minus 3 times 3, which gives us a -13. So our denominator is going to be -13. We replace, let me back up a second here. We replace the 2 and the 3 with the 1 and 21. And find the determinant of the upstairs, which gives us, I believe, if I remember correctly, that was what? 65, a -65, which simplified to a +5. And then to find d sub y, we're going to replace the 3 and the -2 with 1 and 21. And the 2 and the 3 stay there for the coefficients of the x's. And then finding this one, I think we found this to be a +39, if I remember correctly. And 39 divided by 13, -13 is a -3. So the solution, and I prefer that you write your solution as an ordered pair. Write it as the coordinates of a point, because that's what it is. X and Y are where the two lines intersect on the coordinate plane. Now, finding the determinant of a 3 by 3 matrix. So this is when we're trying to find, we use this process to find the unknown, to find the solution to a system of equations with 3 unknowns. So just like with, if you have 2 unknowns, you're finding 3 determinants. With 3 unknowns, you're going to find 4 determinants. The determinant of the coefficients, and then replacing the appropriate column with the constants to find the appropriate d sub x or the d sub y or the d sub z, because now you're dealing with x, y, and z. Now, these are called minors. Minors. These matrices here, or these determinants, I should say, are minors. This is the minor for first row, first column entry. This is the minor for this one. And this is the minor for this one. So how we determine that is I start with this one. So I'm going to ignore this column and this row, and what's left over is the determinant, is its minor. So this is the minor for this one. And that's what they have to. Now for the first row, second column entry. So I'm staying in the first row for these numbers here. These are all first row. So I'm going to do what I did before. I'm going to ignore the column and row it's in, and the remaining 4 numbers create my minor for that. For this entry, this is the minor. And now for this entry, So I'm gonna come back over here, and it's this entry, so I ignore the row it's in, and I ignore the column it's in, and the remaining 4 numbers form the minor for this entry. So row 1, column 3, this is its minor. Row 1, column 2, this is its minor. So you're going to be doing that process. I'm going to talk about the plus and minus signs in a moment. Right now, y'all understand how to set this up, these 3 terms up from this. It's a pretty simple process. It's just keeping straight what numbers you're using. This is a case where having a pencil helps because you can erase. Now, the general form, I always pick the top row. Always, because I do this exact same process every time. So I don't have to remember. The process changes a little bit depending upon where I'm starting from, which row I'm using. Or I could do it using columns instead of rows. I could have done the first column, and then I'd ignore the first column, then I ignore this row, and then this would be the minor for this. It's still the same minor because it's the same entry. And then this would be my second one, and so I would ignore this row. And so this matrix changes because this number changed. And then for the third one, it's the same process, but now I'm ignoring this row as well as this column. So now this is the matrix I would use. So I'm using different numbers than what I have over here. Yeah. This is the only one that's the same. Yep. Now, there's something called a cofactor, and we'll get to that in a little bit. The textbook tends to really stress the cofactor a lot. I don't. Because if you're always doing the first row, then it's these are the signs. It's a minus and a plus. Those signs might change depending upon the sign you get after doing all these multiplies. So this may actually end up being a minus, and this one may end up becoming plus because you might get a negative number here after you find the product here. But the initial sign is minus, the initial sign is plus. And so whatever the sign I get here, that's the sign it's going to be. That's why I like doing the first row every single time. And there's another way of finding the determinant, and I'll get to that later, which is my preferred method. But that's me. So here, this note, and they didn't explain what this is. M 1, 3 is the minor for the first row, second column. First row, second column is that 2 up there. And so I ignore the first row and I ignore the third column. So the remaining 4 numbers, this is the determinant for -2, 3, 5. And letter B, this was letter A. Letter B, M33, well, that's third row, third column. Third row, third column is -2. So I want the minor for this entry. So I'm going to ignore this row and this column. So the remaining 4 numbers, -1, 3, 4, and -2 are the minors for that entry. So this is talking about this minor. Now, I don't worry about this because I'm always going to do the same thing. I'm always going to use the first row. It might be easier to use a different row or a different column because there's multiple zeros along the path. But it simplifies my calculations to keep doing it in the same manner. That's why I always do the first row. And so, yeah, so if this is the matrix, I mean, if this is the determinant we're trying to find, so this is the minor for this entry. Oh, and they found, oh, they did the multiplies. Also, okay, so they did 4 times 5 minus 3 times 2, which would give us what, 26? And then this, what was that? This was, I didn't write the 1 down, -1. So here we're gonna have 2 minus 12, which is a -10. So the second one they ask you to find is going to be, it's going to equal -10. When I do this on paper, like when I create a problem for you all to work, I work the problem out, writing everything down. So -1 times -2 minus 3 times 4, 4 times 3. And then I get 2 minus 12, which gives me the -10. I write it all down. It gets tedious sometimes to do it that way, but if I don't, I come up with wrong answers. Like in the last class period, I came up with wrong answers because I didn't write down all my work, and so I did some things wrong. I got an 8 instead of 16. I wrote 4 instead of 40. Yeah. Okay. Now, this is what is the definition of a cofactor. That means we're multiplying an entry by if the minor of this number, okay, this entry, so the cofactor is this right here. So I add the row and the column, those numbers together, and I raise -1 to it. Right. So you have entry 1, 1, and its matrix, its minor 1, 1. And so it's going to be a -1 raised to 1 plus 1. And the next one, and we put plus here because this determines whether we're going to keep plus or it becomes minus. It's going to be of a sub 1, 2. First row, second column. So its minor is first row, second column. And so the Roman column, 1 plus 2. 1 plus 2 is 3. So that's going to make this minus, because this will be negative. And then the third entry in that row is a sub 1, 3. That's the first row, third column. And its minor is 1, 3. First row, third column. And so I'm going to add the row and the column. So that's 1 plus 3. So that's to the 4th power. So that's -1 to the 4th power, which is positive. So this stays plus. And this stays whatever sign you get from this multiply. And that's why I like to use the top row, because it's always going to be a sub 1, 1 and times its minor minus a sub 1, 2 times its minor plus a sub 1, 3 first row, third column times its minor. That's much easier to remember than trying to remember this here. I understand what it's doing and I know how to do it, but I don't want to have to remember it every time. Because now I can change which row I'm doing, or I can change which column, or what if I'm going by row or going by column. Going by row, the first number in the subscript will be the same. Going by column, the second number in the subscript will be the same. And so, yeah, that's why I like to do the first row. And I suggest you do it too. Sometimes this will show up later on, but when it does, it's a quite simple process. Well, this is something you'll see a lot, because sometimes you want your sign to be positive, sometimes you want your sign to be negative, and so it's going to be a -1 raised to some function up here, which will give you a positive number or a negative number, and some function of n, where n is a natural number. And so you'll either get an even or odd number here, and that'll determine if your number is going to be the opposite or the same, whether you're subtracting or adding. This shows up in sequences. If you have a sequence where the signs alternate, positive, negative, or negative, positive, then it's going to be n plus 1, or which is the same as -1 to the n minus 1. This is the way I'm most used to seeing it, or -1 to the n. This way you start out with positive and then you go negative, positive, negative, positive. This one you start out negative and go positive, so it's negative, positive, negative, positive. Or this sequence would be positive, start out positive, so positive, negative, positive, negative. And in either case, you're alternating your signs, negative to positive, and back again, and back. So it becomes a useful tool. It just the notation and everything confuses people sometimes. It used to for me. Now, to find this determinant, I'm gonna work this two ways. I'm gonna use the first row. So the entry is 2, row 1, column 1. So what's left are these 4 numbers. Okay, so I'm gonna, this row, for the entire thing, I'm not gonna use that row. What's gonna change is the column I'm not gonna use, depending upon whether it's 2, 5, or 0. So it's 2 times its minor. Its minor is the determinant of -1, 4, -2, 6. And then it's going to be minus 5 times, all right? So now we moved on from the 2. Now we're going to look at the 5. And so I'm still going to ignore the top row. And now I need to ignore the column the 5 is in. And so the remaining 4 numbers form my determinant, my minor determinant, 3, 4, 5, and 6. And then now I'm done with that one. And now I move on to the first row, third column, which is 0. Time, and I go ahead and write this down, even though I know it's going to be 0. Doesn't matter what I get for the determinant of this matrix. 3, -1, 5, and -2, because this is just going to be 0. Whatever I get here, I'm going to multiply by 0, which is just 0. And I go ahead and write that down because it tells me that I found that. And then I ignore it from that point on. Okay, so now here I have a 2 by 2 matrix. So it's going to be the product of the main diagonal minus the product of the other diagonal. So it's 2 times a -1 times 6. And I write all this down. The reason I do it is because when I do it in my head all the time, I make too many mistakes doing it that way. So I like to write everything down. And we're subtracting the product of a -2 times 4. So I find out what this is, and then I multiply it by 2. But I'm not going to do that just yet. And it's going to be minus 5 times the determinant here. So 3 times 6, which is 18. Well, let me write it in here. 3 times 6 minus the 5 times the 4. Or they may write it as 4 times 5. It doesn't matter because they're distributive property. And then plus the 0. And now -1 times 6 is a -6. -2 times 4 is a -8. So I'm subtracting a -8. So this is a -6 plus 8. So this gives me 2 times 2. Because -6 plus 8 is 2. Minus 5 times. Well, this is 18 and this is 20. So this is a -2. So this is minus 5 times a -2. And the plus 0, I don't need to worry about. And so I have 4 plus 10, which is 14. Questions here? Any questions at all? Don't hesitate to ask. If you didn't understand any of this, let me know. I'll go back over it. There it is. So a lot of times how I do this, right? This first one here is this 2. So I ignore these and I'm going to multiply this is the remaining, this is the minor for that 2. The next one, I'm going to take the 5 and I'm going to ignore the other numbers in that column, in that row, and then I ignore this column, and I'm going to take these numbers for the matrix here that I'm going to find the determinant of. And then I move on to the 0 over here, and I'm still ignoring that row. But now I'm going to ignore this column and I'm going to use these numbers, these 4 numbers. Realizing that you don't always have a 0 here. This could have been a -8. So that would change our determinant. If that was a -8, then this would have been 22 instead of 14. Because this determinant here is a -1, and -8 times -1 is a +8, so it would add 8 to the 14. But anyway, and that's how they do this. They always look to see which row you have, look to see, do you have a 0 in one of the rows or columns or multiple zeros in the same row or column, and then that's what you would use. I don't worry about that. I just use the top row every time. And so that leads to less confusion when I'm working the problem, which, as you've seen in the past, I need to do. And so they have 2 times this matrix, which is what I have, and then the 5 times this matrix, which I have, and then 0 times this matrix, the determinants of those matrices. And notice they went ahead and found the cofactor in each case. Well, because we're dealing with the first row, that's going to be a +1. This is going to be a -1. And this is going to be a +1. So the signs become whatever sign we get here minus the 5 plus the 0 times. Okay. Because -1 to the 1 plus 1, because we're dealing with the first row, first column. So that's -1 to the 2nd power. Here we're taking the first row, 2nd column. That's where 5 comes from, this first row, 2nd column. So -1 to the 3rd power, which is how we get a negative here, because it's -1 times 5. And plus a -5 is -5. And then first row, 3rd column is where the 0 is. And so I add those 2 together, which gives me 4. -1 to the 4th power is +1, so the plus sign stays. Although with 0, it doesn't matter. And then they got -6 minus 8, -6 minus a -8. And then 18 minus 20, and then the plus 0. So they did the same thing I would do. And then after that, they disregard the 0 because it doesn't add anything significant. And so this gives me a +2, which is what I have here. This gives me a -2, which is what I have here. And then we're adding 4 to 10. I'm going to back up a second here. Because I'm going to do something here. What did I just do?
Remove the third column.
Say again?
You took off the third column.
Yeah, I repeated the first and second column. Because I'm going to be looking at the diagonals. I have the main diagonal and its associated diagonals. And then I have the opposite of the main diagonal and its associated diagonals. And so the reason I extended these over here is because then I look at this diagonal, which is 2, -1, and 6. And then I look at this diagonal. So instead of coming here and then realizing I need to include the 5, since I wrote it over here, then that just extends the appropriate diagonal. And so I'm going to add that product, 5 times 4 times 5. And now I'm going to look at this diagonal, and I'm take the product there. So that's going to be plus 0 times 3 times a -2. And yes, I write it down, even though I know it's going to be 0. That takes care of the diagonals going in the main direction. Now the diagonals going in the other direction, in the opposite direction. What in mathematics, what does opposite usually mean? The positive numbers go this way. Which way do the negative numbers go? In the opposite direction. So opposite means negative, and negative means opposite. So opposite means we're going to be subtracting. So I'm going to subtract the products of the diagonals going in the opposite direction. So I have 5 times 1 times 0. That's going to be -5 times 1 times 0. Yes, I know this is going to go away, but I write it down anyway to show that I did that term. And I will write down a 0 for it. Okay. And now the next diagonal going in the opposite direction, I take that product and I'm going to subtract that product. So it's a -2 times 4 times 2. I'm going to get a negative number here and I'm subtracting it. So I'm actually going to be adding this number. And now we have the third diagonal going in the opposite direction. So that's 6, 3, and 5. So I'm going to subtract 6 times 3 times 5. So 2 times 1 times 2 times negative 1 times 6 is a negative 12. 5 times 4 times 5 is going to be a positive 100. The next one's a 0. The next one's a 0, right? That's supposed to be minus there, but it doesn't matter. 0 times 3 times negative 2 is 0, and 5 times 1 times 0 is 0. And now I'm going to be subtracting a negative 2 times 4 times 2, which is a negative 16. And 2 times 3 times 5, I mean 6 times 5 is 30, and 30 times 3 is 90, so I'm subtracting 90. Next thing I need to do is correct the signs. So I simplify this, negative 12 plus 100. I'm going to ignore the zeros. Minus a negative is plus, and minus 90. So combining my positives, I get 116. Combining my negatives gives me a minus 102, right? 12 and 90 make 102, but they're negative, so it stays minus. And so that is also 14. You may use the minors to solve a system of equations involving 3 variables, or you can use this method to find the determinants to help you find that. Because if you remember on a 2 by 2, where we have A, B, C, D, and we're taking that determinant, we're multiplying the main diagonal, AD, and we're going to subtract the product of the other diagonal going in the opposite direction, BC. That's exactly what we're doing here. We're adding in the products of the diagonals going in the main direction, and we're subtracting the products of the diagonals going in the opposite direction. And to make sure I do this correctly, I can use a calculator to find what each of these individual numbers are, and then use a calculator to combine them correctly. Questions on this? Experiment with it. Try solving a one going both ways, using both methods, and see which method you prefer. Some people prefer this method. I prefer this method. Some people prefer Cramer's rule method. Or not Cramer's rule, but the minors, using the minors. These are all for end up using this in the Cramer's rule, because this is the determinant I would use in Cramer's rule. Any questions here on this? personally, I think for me, using the minors is more confusing than using this method. But that's the way my mind is set. This is the way I learned how to do it. I didn't learn about Kramer's rule. I was taking some serious upper level classes before I learned about Kramer's rule. When I really learned about it is when I started teaching it. But, Kramer's rule is not really difficult. The only issue I see is with the cofactors. And you can keep straight about the cofactors if you always use the first row. And then it's a positive, a minus, a plus. And the signs are appropriate to what the products are. Now, Kramer's rule for 3 equations containing 3 variables for 3 unknowns is the same. Where the D is the determinant of the coefficients, the matrix involving the coefficients, and then D sub X, you're going to replace the column that has the X coefficients with the constants. And then the D sub Y is the same thing. You're just replacing the Y column now, the column of the Y coefficients with the constants. And D sub Z is the same thing. You're just replacing the Z coefficients with the constants. Cool. The constant. So this is the constant column. So when I'm solving for D sub X, I'm going to replace 3, -2, and 4 and 2 with 4, -4, and 4. When I'm solving for D sub Y, I'm going to replace this 2, this 3, and this -3 with this 4, -4, and 4. Appropriately. Okay? And same thing when I'm solving for D sub Z, I'm going to replace these numbers here with these constants. I like to do this way. All right, we have this diagonal. So 3 times 3 times -4 minus this diagonal. So that's 2 times 5 times 2. Right? So to make it more clear, I'm going to write the 3, -2, and 2 here, and then the 2, 3, and -3. And then the third diagonal is this -2, -2, -2, and -3. So -2, -2, and -3. So that's going. I'm still doing plus here. Plus a -2 times a -2 times a -3. And I'll change my whether I'm adding or subtracting appropriately after I find all those products. And now I'm done with those diagonals. And now I do the other diagonal, going in the opposite direction. So 2, 3, and -2. So I'm subtracting the product of 2 times 3 times -2. That means this is going to end up being plus because I have two negative signs. And then this product is going to be minus, right? I'm subtracting all these products, a negative 3 times 5 times 3. All right. Yes, I did. This isn't looking right to me. I don't know. And then the third diagonal, I'm going to subtract this product, right? So that's going to be a negative 4 times a negative 2 times 2. And so now I'm done setting it up. So now I can do my products. So negative 3 times 4 is a negative 36. Did I do that right? Yes, I did. Plus, what is that, 20? And then negative 2 times negative 2 times negative 3 is a negative 12. Right? 2 times 2 is 4, and 4 times 3 is 12. And then 2 times 3 times negative 2. Well, that's a negative 12, so I'm subtracting a negative 12, so that's plus 12. So this minus became 12, it became positive. This is going to be negative 45, and I'm subtracting a negative 45, so it's plus 45. I did something wrong there. No, I didn't. Okay. I don't remember doing this previously. And this is a negative 4 times a negative 2, so that's 8 times 2, which is 16, and we're subtracting 16. So negative 12 and plus 12 go to 0, so I can ignore that. So 20 and 45, 20 and 45 is 65, and a negative 36 and a negative 16 is what? A negative negative 42? No. 52. It's a negative 52. And 65 minus 52 is 13. So to find my d sub x, to find x, so it can be seen, x will equal d sub x over d. Well, d is 13. And then y is going to equal d sub y over d, which is something over 13. And then z is going to equal d sub z over d, and d is 13. And what they do here is they do it by using the minors. They're using the first row. So this will be a positive 1, this will be a negative 1, so this will become minus, and this is a positive 1, so I'm adding a negative, so that's what makes that become minus, provided, yeah. So the determinant here, 3 times negative 4 is a negative 12. Negative 3 times 5 is a negative 15. I'm subtracting a negative 15, so it's going to be plus 15. A positive 15 and a negative 12 make for a positive 3. So this is 3 times 3. So we have a 9 here. Negative 2 times negative 4 is a positive 8. 2 times 5 is 10, so we have 8 minus 10, which gives us the negative 2. Negative 2 times negative 3 is 6. 2 times 3 is 6. So I have 6 minus 6, which is 0. So this term disappears. and this becomes 9 plus 4, which is 13. Now, if you're using minors, show the work here to show me how you got that 3, that -2, and that 0. Because if one of these numbers is incorrect, I need to see how that happened, because usually that's a simple arithmetic error. And if it's not too bad, I can forgive it. But that does affect your answer. So. So now we're going to replace the x coefficients with the constants. And we have this matrix, this determinant to find. And I like to do the I like to show both methods. So we're going to do, and I'm going to rewrite this 4 and a 2, a -4 and a 3, and a 4 and a -3. And so I have 4 times 3 times -4, 4 times 3 times -4, plus 2 times 5 times 4, 2 times 5 times 4, plus the -2 times the -4 times the -3. So we had these 3 diagonals. And we're going to subtract the products of the diagonals going in the opposite direction. So that's -4 times 3 times a -2 minus, so we have this one, and then minus this one. So -3 times 5 times 4, -3 times 5 times 4. And then this product, we're going to subtract. So that's a -4 times -4 times 2. So I'm done setting up my product. So 4 times 3 times -4 is a -48, plus 10 times 4, which is 40. Yeah, in my 10 o'clock class, I wrote this down as a 4, which gave me the wrong answer. Okay. And then a -2 times -3 times 4. So that's a -24. So that's plus a -24, which is -24. And then we have 4 times 3 times -2. So we're subtracting a -24. Here we're adding -24, and here we're subtracting 24, a -24. So this is going to end up being 0. And then we're going to subtract a -3 times 5 times 4. So 5 times 4 is 20, and 20 times a -3 is a -60. So that ends up being plus 60. And then -4 times -4 is 16. 16 times 2 is 32, and we're subtracting that. Now my next line is that I'm going to simplify the signs. So I have a -48 plus 40 minus 24 plus 24 plus 60 minus 32. All right, the minus 24 and plus 24 go to 0. This is 40, not 10, Thomas. So 40 and 60 is 100. And then the negative numbers, negative 48 and a negative 32 make for a negative 80. So we have a minus 80. So that's going to be a positive 20. So d sub y is 20. No, that was d sub x. So that's 20. Okay. Now, the way they do it, they set it up. The 4 times its minor, the 2 times its minor, which is the 4, 5, 4, negative 4. And then the negative 2 times its minor. And this is going to be a positive 4. This is going to be a minus 2. And because this is a negative 2, then it's going to be minus 2. So I would do it this way. 4 times 3 times a negative 4 minus a negative 3 times 5 minus 2 times a negative 4 times a negative 4 minus 4 times 5. And then we have plus a negative 2 times, am I going off screen? I think I am. Negative 4 times a negative 4 minus, no, negative 4 times a negative 3 minus times 3. All right, this is going to give me a negative, this is going to give me 12 minus 12, which is 0. And so this is plus 2 times 0. Now I get 4 times negative 12 plus 15, because a negative 3 times 5 is negative 15, minus the negative 15 is plus 15, minus 2 times negative 4 times negative 4 is a positive 16, minus 20. And then, like I had said before, we get a negative 2 times 12 minus 12. This gives me 4 times 3. This gives me a negative 2, a minus 2 times a minus 4. And that's plus 0. Or I could write it down as negative 2 times 0. And so this is 12. Negative 2 times negative 4 is 8, plus 8. And then we're just adding 0, which is 20. It's the same number. I like to write it down, showing all the operations I'm doing. So I go back and review what I did to make sure I got the right number. Three times 4 is a negative 12. Negative 3 times 5 is a negative 15. Negative 12 minus a negative 15 is a positive 3. Negative 4 times negative 4 is 16. Well, 4 times 5 is 20, and 16 minus 20 is a negative 4. Negative 4 times 3 is 12. Negative 4 times negative 3 is 12. And 4 times 3 is 12, and 12 minus 12 is 0. And the reason I want you, if you're using this method or either method, please show all the operations you're doing. So if you wind up getting an incorrect number, I want to know why. So I can see, is it an arithmetic error or is it a systemic error? Are you doing the processing correctly, or you just did an arithmetic error? Arithmetic errors are worth 1 or 2 points. If you do more than one arithmetic error, then that's going to be a point or 2 definitely taken off. But if it's a systemic error, then that's a -3 or more. So I need to see what happened. So if you don't get a 3 here, I cannot automatically assume that it's an arithmetic error. It may be a systemic error. How you're finding this determinant here might be wrong. And so you might lose more points because of that. So here, I'm not going to go through my way of doing it because it's going to take quite a bit of time here. But I will do it on letter Z. I'll do the diagonals for Z. So we do -4 times -4, which is 16. 4 times 5, which is 20. So I get another I get a -4. 3 times a -4. And then, right, because that gives me 16, and that gives me 20, and 16 minus 20 is a -4. So that'll be -3 times a -4. And then this gives me a +8, and this gives me 10. So 8 minus 10 is -2. So I get a -4 times a -2. Right, because the cofactors, this is a +1, this is a +1, and this is a -1, so that becomes minus in here. And this -2 is going to make this be a -2 times. -4 times 4 is -8. 2 times -4 is -8. -8 minus -8 is 0, so this becomes -2 times 0. So we had 3 times a -4, and -4 times -2, so I have a -12 plus 8. -12 plus 8 is a -4. I didn't show that extra step in there. And that's what I mean by showing all your work. You show all the steps. You don't skip steps like they do. So my numerator here, my numerator here is a -4. Does 13 divide 20 evenly? Does 13 divide -4 evenly? No, then just leave it as a fraction. Don't type it into the calculator. Just leave it as a fraction. All right. The main diagonal, 3 times 3 times 4, 3 times 3 times 4, plus, and now it's going to be 2 times -4 times 2. So 2 times -4 times 2, plus, and then the third diagonal, the 4 times -2 times -3, 4 times -2 times -3. Now I'm done multiplying all three diagonals going in the main direction. And so see that that's why I write it. I'm going to rewrite it down here. 3, 2, 4. -2, 3, -4. And 2, -3, 4. And then I write the 3, 2, the -2, 3, and the 2, -3. So I can show these diagonals going this way. And now I have the diagonals going the opposite direction, which I'm going to subtract those products. So now I have 2 times 3 times 4. 2 times 3 times 4 minus. And then the next diagonal, -3, so I'm subtracting a -3 times, there's a negative sign with this 4, -4, and then a +3, minus the third diagonal going in that direction. And so that's 4 times -2 times 2. 4 times -2 times 2. 3 times 3 times 4 is 36. 2 times -4 times 2 is a -16, so that's -16. 4 times 2 times 3 is a +24. Minus 3 times 2 times 3 times 4, which is -24. -3 times -4 is +12, and 12 times 3 is 36. So I'm subtracting 36. And 4 times a -2 times, well, a -4 times a -2 times 2 is a +16. Well, here I have a +36 and a -36. Here I have a -16 and a +16. And here I have +24 and -24. So it is just 0. And 13 does divide 0 to a nice integer number. Now, doing it using the minors, you should hopefully would get zeros. So here I have 3 times 4 and -3 times -4, so I have 12 minus 12, 0. And here I have a -2 times 4, which is a -8, and 2 times a -4, which is -8. -8 minus -8, 0. And here I have -2 times -3, which is 6, and 2 times 3 with a 6, which is 6. So now I have 6 minus 6, which is 0. So it's going to be 3 times 0 minus 2 times 0 plus 4 times 0. So I have 0 minus 0 plus 0, which is not 0. So they go, and I like to find these numbers as I'm going along. I just think it's simpler that way. And so write it as an ordered triplet. 20/13, comma, -4/13, comma, 0. Now, for an inconsistent or a dependent system, an inconsistent system means you have no zero, you have no solution. An inconsistent is no solution. Now, to have a dependent system means you have an infinite number of solutions. So it's a consistent, the system is consistent because you get solutions, but you get an infinite number of them, or infinitely many. When I first started teaching, they said an infinite number of solutions. And they switched the nomenclature to say infinitely many solutions. Means the exact same thing. So I say both ways. My default way, especially when I'm tired, is just say infinitely many. All right. So if in both cases, for it being inconsistent or dependent, the determinant of the coefficients is 0. Well, if one of the other determinants, d sub x, d sub y, or d sub z, is not 0, then it's an inconsistent system and the solution set is empty. Both these symbols here mean you have no solution. This is an empty set. There's nothing in the set between the two braces, which shows us that this set is empty. This symbol, I usually think of that symbol meaning the null set. I have a friend, he lives, I think he's in San Diego now. He used to be in the Detroit area, and then he moved over to San Francisco, and then he moved down to the Los Angeles area. He's an author, and he has a publishing company that publishes his books, and it's called Empty Set Publications. And this is what they use for the symbol of their company. He and his wife, right? Okay. So if the determinant of the coefficients is 0, and one of the other, the dx, dy, or dz is not 0, then you have an inconsistent system and you have no solutions. If the determinant of the coefficients is 0, and all three of the others are 0, then the system is consistent, which means you get a solution, and dependent. So that means there's an infinitely many solutions, and you have to solve it using row reduction techniques. You may see that in the homeworks, but you will not see that on an exam. Now, these next set of we're gonna have a series of theorems here, and I'll just bounce through them because we just talk about them. We don't do anything with them in this course. So the value of a determinant changes sign if any two rows or columns are interchanged. So you switch up two rows, or you switch up two columns, you're going to get the same determinant, but it's with an opposite sign. And they show an example. All right, the determinant here is a -7. I mean, a -17. All right, and I think they switched. I think they switched the rows. Yeah, they switched the rows. So instead of it's 5 times a -1 subtracting this, the 2 times 6. Now it's the 2 times 6 subtracting the 5 times the -1, which is 12 plus 5. So the subtraction's going the opposite direction is what happens. And so instead of getting a negative number, you get a positive number. All right, if all entries in any row or any column equals 0, then the value of the determinant is 0, because you're always multiplying all your products, you're going to be multiplying by 0. Whether you're doing the minors or you're doing it by the diagonals, you're going to be multiplying by zeros. So all of your determinants would end up being 0. I mean, all your values that you're going to combine are going to be 0. If any two rows or any two columns of a determinant have corresponding entries, that means, well, they'll show an example. Then the value of the determinant is 0. All right, the example they give is the top row and the third row are the same. They put that in a note down here. Note the first and third row are the same. And so they go through the process of finding those determinants. All right, -3 times 3 is 9, -9, minus the -1, which is going to be -8. And then 3 minus 2 is 1. So it's 1 times 1. And this is going to be a negative. So negative times negative is positive. So that's why it's plus. And this is going to be a positive. So it doesn't affect that sign. And so 1 times -1 minus 2 times -3. So -1 minus a -6, which is -1 plus 6, which is 5. And so you have a -16. This is -16 plus 1 plus 15, which is in fact 0. And this is just an example that shows you why that it's an example of the theorem. It doesn't prove the theorem. It's just an example of showing you what happens when that happens. It's a demonstration. Any row or column multiplied by a determinant of a determinant is multiplied by a non-zero number x, then the value of the determinant is also changed by a factor of x. So you multiply one row by k. That's like finding the determinant and then multiplying that number by k, which is what they do here. So they show you this. So the determinant here happens to be -7. So if we multiply the top row by k, okay, and find the determinant, where K is any real number, not 0. All right, so then we have this gives us -10, and this gives us, negative 10K, and this gives us negative 3K, and I'm subtracting a negative 3K, which means I'm adding 3K to a negative 10K, which gives us a negative 7K. So that's multiplying this determinant by K, which is what they show here. Because 7, right? 7 is the determinant of this matrix, so we're just multiplying K times the determinant of this matrix. So this is demonstrating that theorem. Do you need to know this for a test? Nope. But it's in the curriculum and it says we're covering this, and so here we are. If the entries of any, all right, so if you do a row operation on two rows or column, by multiplying one row or column by a number that isn't 0, and add it to the corresponding entries to a row or column, the value of the determinant remains unchanged. So you're not going to change the determinant simply by using row operations to change the numbers. So what they're going to do is they're going to change this. First, they're going to find this determinant. So we have 7 times 3, which is 21, and 2 times 6. 2 times 6 is 12, and so 21 minus 12 is 9. Well, they're going to do row operations on this to make this 6 become a 0. So they're going to multiply the bottom row by -2 and add it to the top row. So the 7 becomes 3 and the 6 becomes 0. -2 times 2 is -4. -4 and 7 is a +3. -2 times 3 is a -6, and -6 plus 6 is 0. And now to find the determinant, 3 times 3 minus 2 times 0. 2 times 0 is 0, so you get 9 minus 0, which is 9. So if you do row operations to change one of the numbers or all of the numbers in one row, then you're not gonna change what the determinant is. That is different than switching the rows. I'm going to get into this a little bit. A sequence is a function whose domain is a set of positive integers. I like to say, the way I learned this is instead of positive integers, is a set of natural numbers, 1, 2, 3, the counting numbers. And the range is a subset of the real numbers. So you get so your range is a bunch of numbers that are real numbers. So we're going to do something to the natural numbers and get another number, which is going to be a real number. This sequence, A sub n, when it's written this way inside the set notation, this tells me we have a sequence. A sub n, the n tells me what term it is. The first term is a sub 1. The second term is a sub 2. The third term is a sub 3. The fourth term is a sub 4. The fifth term is a sub 5. And the sixth term is a sub 6. And that's what they were asking for here. So I'm going to put the term number in for n. So when n is 1, then this is going to be 1 plus 2 divided by 1, which is 3. And when it's 2, it becomes 2 plus 2 divided by 2, which is 2. 2 plus 2 is 4, and 4 divided by 2 is 2. And then 3 plus 2 divided by 3 is 5 over 6. I mean, 5 over 3, sorry. And then putting 4 into play, we get 4 plus 2 divided by 4, which is 6 over 4, which is 3 halves. Putting 5 in for n, we get 5 plus 2 over 5, which equals 7 fifths. All right. If you can simplify the fraction, simplify the fraction. Otherwise, don't mess with it. And then putting 6 in for n, we get 6 plus 2 divided by 6, which gives us 8 over 6, which is 4/3. So those are the first 6 terms in the sequence. 3, 2, 5 over 3, 3 over 2, 7 over 5, and 4 over 3. And there's more numbers in the sequence, but we stopped at the first 6. And so here's that sequence. Actually, we wouldn't run. We just They showed the process in finding the first 3 numbers in the sequence, and then they left it to you to find the rest of them. So I'm going to stop here because we're almost to time. My question to y'all is, do you have any questions?
Sir, I saw that on my lab, there's no assignment for the section that we just finished.
Well, there isn't.
No, I didn't see any.
Okay, I'll go in and look.
What section is it again? What number?
Section 11.3.
Okay, yeah, no, it's not on there.
It's not on there.
It's only up to 5.8.
5.8.
Yes, it goes 5.5, 5.6, 5.7, and 5. Those are the only
I don't think it'll have my.
dimension.
I need to go check that all out. Thank you for bringing that to my attention.
You're welcome.
Because what that tells me is that let's stop the recording.